Hello guys, now we are going to do one more topic, and welcome to my channel, which is Chemistry Live with Dr. Rishi. So today we are going to cover one important topic, which is of plus 2 chemistry, and the chapter name is solution. Actually this is the second chapter of your chemistry syllabus. So in this chapter there's a one topic which is actually the concentration based, and you need to do a lot of formulas for this, and you need to do the numerical questions actually. So they have been a mass percentage, volume percentage, molality, normality, even the mole fraction and part per million. You need to do this. Now we are going to do important topic, which is about the Henry law. So basically Henry law start with this, that you need to understand the term solubility. Solubility is basically dissolution of one component to the other. So there are basically two criteria that you need to understand the solubility, and these laws can be covered. One is most important law in this chapter is one is Henry law, and second is Raoult's law. So today we are going to cover with this Henry law. Actually, you need to understand the solubility of gas in a liquid. This is the one important topic, and solubility of liquid in liquid, that is the second topic. So basically, if you can focus on this topic, that solubility of gas in liquid, you need to keep in mind that we are solubilizing the gas in a liquid. So basically it will work with the pressure, because we count pressure for the gas. But when we comes to liquid in liquid, we goes for the partial vapor pressure, because it is a liquid. So it is a partial pressure for the gas in liquid solubility, which comes out with the Henry laws, and second with the Raoult's law. So coming to the Henry's law. Henry law, the statement says that you can easily understand that what is the statement all about. It says at constant temperature, solubility of gas in a liquid is directly proportional to pressure of the gas. So you can clearly understand the temperature is kept constant, and this term solubility of a gas in a liquid is directly proportional to the pressure of the gas. So we can clearly say the pressure and the solubility both are related to each other. If you increase the pressure, solubility will increase. In the second definition, there is one more definition which can relate mathematical to the numerical problems also. So it is called partial pressure of a gas in vapor phase is directly proportional to the mole fraction of the gas. So basically in this, you are relating the partial pressure of a gas with that of mole fraction. Mole fraction is the term which is referred to the solubility of a gas. Basically, if you convert to this in the formula, so you can relate that if P is directly proportional to this X, you can also term that a mole fraction. The original word is called chi. So basically, if you remove this proportionality constant, you will apply a constant. So you get the KH, and KH is called Henry constant. And we can also relate that the term P is pressure and X is mole fraction. Basically, you can also understand that mole fraction is basically related to the solubility. So if KH and mole fraction can be related, so you can understand if KH value increases, solubility, only this term solubility will decrease, right? So if you have given the KH of 2, 3 or gas, like there are 2, 3 gases for which KH is given, so you can basically see which is having more value of KH, so that will be less soluble in the given medium. You can easily understand that value of KH is also related to the mole fraction. So basically increasing the value of KH will result in the decreased solubility of that gas in that medium. Clear? One more important aspect of this topic is that you need to do the various application of the Henry law. So there are basically 4 applications in your NCERT book. We will discuss one by one. So first one is that we all know that aquatic species feel more comfortable in cold water than in hot water. Actually, this is the topic that why these all application can come in the exam, that why aquatic species feel more comfortable in cold water than in hot water. So we can basically relate this with the temperature also. Solubility is related to the temperature. If temperature will increase, solubility will decrease. So basically, aquatic species are taking oxygen from the dissolved state, and they are taking from the water. So more oxygen will be available in cold water because hot water is having more temperature, and temperature is related to the solubility. So you can visualize that hot water is having less amount of oxygen and cold water is having high amount of oxygen. So they go to the cold water to carry the oxygen amount in sufficient amount. The second application is that's solubility of CO2 in the cold drink or soft drink. So these bottles of cold drink and soft drink, these are called actually carbonated water, are sealed with high pressure of CO2. Basically, if you open that cold drink bottle, so there's a voice that comes out that CO2 is gas removed from that liquid. So basically, high pressure bottles are sealed with the high pressure of CO2. So they increase the solubility of CO2 in that carbonated drinks. It is a very interesting example which you can visualize by using the practical application. You take a bottle and open it, so you feel that there's a gas coming out. So basically the bubbles that are due to the CO2. In the third application, scuba divers which go inside the sea and other water areas, they always must cope with high concentration of dissolved gases while breathing in air at high pressure. When they go inside the water and deep water, so they need to take the oxygen cylinders, and with the oxygen cylinder they also take some other gases, because when underwater they goes, pressure increases, which increases the solubility. Now you can also relate this. This is the term which is Henry Law is saying, that pressure increases the solubility, and if solubility of these gases will increase in the blood, so more oxygen will be required. To supply this amount, non-reactive helium gas is also given with the oxygen cylinder to meet the pressure of the gas with the tissue or that blood cells. In the last application, which is climbers at high altitude, like basically if you go in the high altitude of the mountain, you feel weak and your breath comes like heavy breaths is there, because there's a low partial pressure of oxygen, and as a result there will be a low level of oxygen in your blood cells, and sometimes the persons living in these areas, high altitude areas, they are suffering with the problem that is called anoxia. Basically, anoxia is the related low concentration of oxygen in tissues, resulting in the weakness and decrease in the thinking ability. So this is the term called anoxia. Now we have understood that we have 4 applications of this law. One is called aquatic species, why they are more comfortable. Second one is carbonated drinks. Third one is scuba divers, and fourth one is anoxia, or climbing high altitude, like you can say high altitude problem. So okay guys, you now can understand the Henry law and its application. Thank you.